Hi everybody, welcome to the review for Unit 3 Part 2. So we're going to start here with number 1, which lines are parallel. So to be parallel, here's our little symbol for parallel. We need to have the same exact slope. So if I look at these two that are already in slope-intercept form, I notice that their slopes are not the same. One is positive, one is negative. So I'm going to see if I can match 3 over 2. So I'm going to get y by itself by subtracting 3x to the other side and dividing both sides by 2. So I see this slope is negative 3 over 2, and this slope is negative 3 over 2. So those are parallel. I'm going to work with this one over here, again getting y by itself. So negative 2y is equal to negative 3x plus 6. Divide both sides by negative 2. And I see that negative 3 divided by negative 2 is positive 3 over 2. Which matches here. So those two are parallel. Sorry, a little typo over here. Make this 4x equals y plus 9. Which lines are perpendicular? So I'm looking for opposite reciprocal slopes. Opposite reciprocal slopes. So I'm going to get this y by itself by moving the 5x to the other side and dividing by 4. Is negative 5 over 4 opposite reciprocal of 4? Absolutely not. Let's look at this one. I'm going to get y by itself by moving x to the other side and dividing by 4. Is negative 1 over 4 opposite reciprocals with 4? Yes. So these two are perpendicular. Opposite reciprocal means opposite sign. So this is negative, this is positive. And reciprocal means the fraction is flipped. So 4 over 1 flipped over is 1 over 4. It's opposite reciprocal. Okay, let's see about this one. If I get y by itself, that's 4x minus 9. Nope. Not opposite reciprocal. Okay, in number 3, it actually doesn't say how to write my line. So I'm going to write it in point slope form because I can. It doesn't say how to write it. So first I need to know my slope. To be parallel, same slope. So I'm going to get y by itself. And I'm going to be using a slope of negative 3 over 5. Has nothing to do with the y-intercept. Don't even worry about that. Here's my slope. Here's my point. Y minus 2 is equal to negative 3 over 5, x minus 1. Now from here, I could put this into slope-intercept form. I can put this into standard form. And I'm going to have to do that later. Just it didn't specify what way to put it on this one, so I'm just going to leave it like that. All right, number 4 says find the line perpendicular. So I'm going to take the slope, which is negative 2 over 1. So I'm going to do the opposite reciprocal, flipping the fraction, changing the sign, would be positive 1/2. Again, they didn't specify which way to write it, so I'm just going to write it into point slope form. Okay, again in number 5, they actually specify point slope form. So what I'm going to do is draw a line of best fit. Just the best that I can, kind of draw a straight line that is going to go through as many of these points, get as close to these points as possible. So I think that's about good. Well, now it moved. Think about probably about there. So it's actually going straight through that point 60, 50. And it looks like it has a slope of 1. And look at the scaling. It's going by 10. So up 10 over 10, up 10 over 10. So my slope is 10 over 10, or 1. So point slope form, y minus 50 equals 1, x minus 60. The next one I'm going to need my graphing calculator for. Oh, hang on just a second. The table below shows Mia bowling scores every year when she participated in the bowling league. So on my home screen, why aren't you working? Hello? Oh, now it's frozen. Great. Hang on a second. All right, there we go. So on my home screen, I'm going to start a new document. I'm going to add lists and spreadsheets, and I'm going to type my independent variable at the top. My independent variable is weeks. My dependent variable is scores. So my weeks go 1 through 6, and my scores are 122, 131, 130, 133, 145, and 139. Oops. Make sure you press enter. Now we go to Document, Insert, Data and Statistics. Click your independent at the bottom. Click your dependent over here on the side. Menu, Analyze. Regression, Show Linear. And there's our equation, 3.71429x plus 120.333. It says to find the R value, so I'm going to go back to this page. I'm going to go to Menu, Stats, Stat Calculations, Linear Regression, MX plus B. I have to change this to my X, and this to my Y, and then my R value is 0.877. So that is showing us a pretty strong positive correlation here. Pretty strong. Not super, super strong positive, but it's definitely a strong positive. Okay, finding an inverse algebraically. So there are 2 steps here. There's a switch x and y, and there's solve for y. Just 2 easy steps. So f of x is the same thing as y, so now I'm going to switch them. X equals 6y, Patricia, plus 3. Get y by itself. So my inverse is x minus 3 over 6. I see all these opposites. Plus 3, minus 3. Multiply by 6, divide by 6. On the number 8, I'm actually going to do it 2 different ways to kind of show you what you can do. One thing is I can distribute this before I get started. Whoops, that's a y then. And I can do that. And then it's real easy. X plus 20 equals 12y, divide by 12, divide by 12. And my inverse would be x plus 20 over 12. I don't like to do it like that because I can't see opposites. Plus 20, was there a minus 20? I mean, technically, but I like to do it without distributing. They are actually the same exact answer. X equals 4, 3y minus 5. I just like to see the opposites. So x divided by 4 equals 3y minus 5. X divided by 4 plus 5 equals 3y. And then to make this look nice, instead of dividing everything by 3 and making a fraction within a fraction, I make it 1/3 x over 4 plus 5 as my inverse. So there are many different ways that you can write your inverse. These are actually the same exact thing. This and that are the same. They're just written a different way. It doesn't matter how you want to do it. It really doesn't matter. I like it just like this because I like to see my opposites. So I like to see that I'm dividing by 4 instead of multiplying by 4. Multiplying by 1/3 instead of multiplying by 3. Adding 5 instead of subtracting 5. Oops. Okay, write the equation of the line in slope-intercept form, find the inverse, graph the inverse. So first, this crosses at 6, and the slope is down 6 to the right 4. Reducing that fraction is -3/2. Now to find the inverse, I'm going to switch x and y and solve for y. Okay, right here. You normally do not see a negative left in the denominator like that. Usually what they do is they'll write -2x plus 12 over 3, and they kind of switch every single sign. So switching that sign to a negative, switching that sign to a positive, switching that sign to a positive. Normally that's how you see it. Either way is correct, but this is easier to look at for graphing. So that's -2/3 x plus 4. So I'm going to go up to 4, and I'm going to go down 2, remember how it's scaled, over 3. Down 2 over 3. So I see that my graph crosses. Does it cross at a right angle? Absolutely not. It's not perpendicular. But they do cross right at this line, y equals x, that goes through the origin. Always, always, always are they going to cross along this line. Look at the opposites. Add 6. Well, we don't see that. But we're adding, and it was subtracting. That's why I don't like when you have to do this, but you have to graph. I like to see my opposites, but you can definitely see that your slope is opposite. Not opposite reciprocal. It's not supposed to be like that. It's not perpendicular. Okay, in a certain lake, a 1-year-old bluegillfish is 3 inches long. A 40-year-old bluegillfish is 6.6 inches long. Assuming the growth rate can be approximated by a linear equation, write an equation in slope-intercept form for the length of a bluegillfish in inches after t years. Use the equation to determine the age. So age, length, age, length. The length depends on the age. So I'm going to find my slope. 6.6 minus 3 over 4 minus 1. That's 3.6 over 3, which is 1.2. Y equals 1.2x plus. Now I'm going to think about my b. What does b mean? What's a y-intercept? It's your starting point. So when the bluegillfish is born, how big is it? 1.8. Because at 1, if it was at 3, we got to go back 1.2. So 3 minus 1.2 gives me my 1.8. Now to use that, it says determine the age. Oh, I forgot. It says t years, so I guess a t here instead. Determine the age. So I'm determining t if it is 9 inches. Inches are a y. So I have 9 equals 1.2t plus 1.8. Or subtract 1.8 from both sides. 7.2 equals 1.2t. Divide by 1.2. And I get that he's 6 years old. 6-year-old little fishy. 9 inches long. Okay, correlation or association. Correlation means it definitely causes something else. There's no lurking variable that's making this happen. Association means it's kind of just a coincidence. So the number of people who drown by falling in a swimming pool is proportional with the number of films Nicolas Cage appeared in. Well, obviously that's not true. Association. It could have happened. You could graph it out and you could see that it's positively correlated or negatively correlated, but is it really like that? No. A controlled study showed that people pulled over for texting is proportional to the number of accidents on the highway. Absolutely, correlation. Those can cause one another. Per capita consumption of cheese is indirectly proportional with the number of people who die by becoming tangled in their bed sheets. No, association. Okay, I'll do the rest in part 2.